You know how we all have our own, like, languages,
Yeah.
ways of communicating?
Yeah.
Well, get this. There's a whole visual language uh, that's dedicated to keeping aircraft in the air.
Huh.
We're doing a deep dive into aviation drawings today.
It's amazing how something as simple as lines on paper
Right.
can be so powerful
Yeah, it's incredible.
in this industry.
We've got excerpts from the Aviation Maintenance Technician General Handbook to guide us. Now, I know what you might be thinking at home. I'm no mechanic.
Right.
But trust me, this stuff is interesting, even if you've never set foot in a hangar.
It really is. And think about it this way. A misplaced comma in a written instruction could lead to, well, a big problem in any field,
Right.
right? But when you're talking about aircraft, the stakes are just so much higher.
Yeah, that's a good point. So these drawings are like the ultimate insurance policy against miscommunication.
Precisely. And they've evolved so much over the years. I mean, we've come a long way from just pen and paper on those giant drawing boards.
Oh, yeah, I was reading about that. Now it's all computer graphics and software like, what was it, CAD?
Yeah, CAD or computer-aided design. But that's only one part of it. There's also CAM, which stands for Computer-Aided Manufacturing. These days, an entire aircraft can be designed digitally before a single piece of metal is even cut.
Wow. So you're saying they basically build the entire plane in the computer first.
Exactly.
That's got to reduce errors, I would think.
Absolutely. And the software used is incredibly sophisticated. Programs like CATIA, it's used by companies like Boeing. It's almost like the Photoshop of aircraft design,
Huh.
allowing for amazing detail and precision.
And the cool thing is the handbook says these digital models are accessible now on laptops and tablets right on the shop floor.
It's a far cry from lugging around those giant blueprints,
Oh, yeah?
with all the tracing and chemically treated paper. You had to expose them to light. It
Yeah.
was like developing a photograph almost.
I can't even imagine trying to lug those around, but it makes you appreciate the precision that's always been a part of aviation.
Yeah, and to make sure everybody's working from the same page, there are different types of drawings,
Uh-huh.
each with a specific purpose.
Like, what kind of drawings are we talking about?
Well, imagine putting together a model airplane.
Okay.
You'd need different instructions for each part.
Yeah. You'd need, like, a close-up view for each piece.
Exactly. Those are your detail drawings. Then you'd need instructions for how all those pieces fit together.
Okay.
That's your assembly drawing. And finally, you need to know where to place those assembled parts within the entire structure.
Gotcha.
That's your installation drawing.
So it's like different levels of zoom,
Mhm.
from the tiny detail all the way to the big picture.
Exactly.
Okay. So what about when you need to see the inside of a part? How do they do that?
Ah, that's where sectional views come in, like
Yeah.
taking a virtual slice through a part to reveal its inner workings.
Like those diagrams where it shows you half a car engine or something?
Exactly. And there are different types of sectional views depending on what you need to see. You have a full section, which cuts straight through the object. You have a half section, which shows half the inside and half the outside.
Okay, so you'd use a half section if you wanted to show something symmetrical.
Precisely. And then there's a revolve section. It's like taking a thin slice and spinning it around to show its shape.
Okay. We've got these different views, different levels of detail. It really is like a whole new language, isn't it?
And like any language, these drawings have their own grammar. For example, each drawing has what's called a title block.
Yeah, the handbook mentions that.
Hmm.
What exactly does the title block tell you?
Think of it as the drawing's passport.
Yep.
It includes all the essential information, like the drawing number, the name of the part, the scale, the date it was created, and even who drew and approved it.
Hmm.
Traceability and accountability.
So every drawing has this unique identifier. What about just knowing the size of the drawing itself?
That's where the universal numbering system comes in. Whether it's a letter-size drawing or a massive one that covers a whole wall, this system ensures everyone knows what they're looking at.
It's amazing how much information is packed into these drawings, but I bet when it comes to aviation, precision is absolutely critical.
Oh, absolutely. Even the tiniest error can have huge consequences. Imagine a door that's just a fraction of an inch too big. It simply wouldn't fit. Now apply that same concept to a critical aircraft component.
Yeah, a slightly off measurement suddenly becomes a much bigger deal.
Exactly. And that's where the concept of allowances and tolerances comes in. Essentially, these are the acceptable margins of error for a part's size.
So it's not about being absolutely perfect, but being within a very specific range.
Precisely. And the level of tolerance varies, of course, depending on the part and its function. A critical component, like a wing spar,
Right.
will have a much tighter tolerance than, say, a piece of interior trim.
That makes sense.
Yep.
And are these tolerances spelled out directly on the drawings?
Absolutely. You'll often see numerical values, plus and minus signs, and even symbols to communicate the acceptable range of variation. It's all about clarity, making sure everyone involved in the manufacturing and assembly process is working with the same understanding.
It's like a secret language within a language?
It is. It is. And in addition to tolerances, you have what are called finish marks,
Okay.
which indicate how smooth a surface needs to be.
Why is the smoothness of a surface important?
Well, think about the airflow over an aircraft's wings.
Right.
A rough surface creates more drag,
Uh-huh.
reducing fuel efficiency.
Mm.
So even something as seemingly minor as surface texture can have a big impact on performance.
It's amazing how every detail matters in aviation.
It really does. And speaking of details, we were talking about the grammar of these drawings earlier and, the title block.
Yeah, it's like the drawing's ID card.
Right. But in addition to that basic information, drawings also use a variety of notes and symbols,
Okay.
even zone numbers to convey critical information.
This is starting to sound like deciphering a treasure map.
Well, it's not quite that cryptic, but there is a logic to it. Think of the notes as little whispers from the engineer to the technician, providing additional context and instructions.
Okay, so it's not just about the lines and the shapes, but also these textual clues.
Exactly. A note might explain a specific method of attachment, offer an alternative design, or highlight potential modifications. It's all about making sure everyone involved has a complete understanding of the part and its function.
What about the symbols?
Symbols are like shorthand for common features.
Gotcha.
They represent things like different types of materials, shapes, or even electrical components.
So it's a way to convey a lot of information very concisely.
Exactly. And to help navigate these often complex drawings, there are zone numbers.
Okay.
Imagine a grid system laid over the drawing.
Mm.
That's essentially what zone numbers are. They divide the drawing into sections, making it easier to locate specific details.
Like a built-in GPS for the drawing. But let's talk about the real heart of these drawings. The dimensions. I can only imagine accuracy is absolutely paramount here.
You're absolutely right. Even the slightest deviation can have significant consequences.
Right. We talked about allowances and tolerances earlier, but how are dimensions actually represented on the drawings?
Well, one of the most fundamental concepts is orthographic projection.
Okay.
This is a system of representing a three-dimensional object using multiple two-dimensional views.
Right, I remember seeing those in the handbook. Front view, top view, side view, like taking snapshots of the object from different angles.
Exactly. And by combining these views, you get a complete and accurate representation of the object's shape and dimensions.
But what about when you need to see a specific area in greater detail?
That's where detail views come in, like zooming in with a magnifying glass to show the finer points of a specific area.
And then there are the sectional views we talked about earlier, which allow you to see the inside of a part.
Exactly. Full sections, half sections, revolved sections, they all serve a purpose, depending on what you need to see.
It's like having X-ray vision for aircraft parts.
Mm.
But beyond these more technical views, the handbook also mentions things like pictorial drawings and diagrams and flowcharts. What are those for?
These are more about communicating information quickly and efficiently. Pictorial drawings are like photographs,
Okay.
giving you a realistic view of the object. Diagrams show how different parts are connected and interact, like a roadmap for a complex system. And flowcharts illustrate a sequence of events or steps, which is helpful for things like troubleshooting.
So they each have a specific purpose, but they're all about communicating clearly and avoiding ambiguity.
Precisely. And these days, digital images are also becoming increasingly important in aviation maintenance.
Yeah, I can see how a photo of a damaged part could be incredibly useful for troubleshooting.
Exactly. It allows technicians to share information quickly and easily, almost like having a virtual inspection team at their fingertips.
So we've gone from those giant, unwieldy blueprints to digital models and images that can be accessed anywhere in the world. It's amazing how technology has transformed this whole aspect of aviation.
It really has. But even with all these advancements, the fundamental principles of clarity, precision, and standardization remain as important as ever.
It's a testament to the incredible ingenuity and collaboration that goes into keeping aircraft safe and in the air.
Absolutely. And our journey through this fascinating world isn't over yet. In the final part of our deep dive, we'll explore some of the challenges and future trends in aviation drawings.
I can't wait to see what the future holds for this hidden language of aviation.
It really is. But even with all these advancements, the fundamental principles of clarity, precision, and standardization remain as important as ever.
Yeah, absolutely. It's a testament to the incredible ingenuity and collaboration that goes into keeping aircraft safe and in the air.
Absolutely. And our journey through this fascinating world isn't over yet. In the final part of our deep dive, we'll explore some of the challenges and future trends in aviation drawings.
Can't wait to see what the future holds for this hidden language of aviation. We're back for the final part of our deep dive into aviation drawings, and we've covered a lot of ground from those old blueprints to the importance of tolerances and those really detailed sectional views. But with technology changing so rapidly, I'm curious, what are some of the biggest challenges facing the world of aviation drawings today?
That's a great question. I think one of the biggest challenges is just keeping up with the pace of change.
Right.
You have new software, new digital tools, new drawing standards. It's a lot for people to stay on top of.
It's like needing to learn a new language every couple of years. How do people in the industry even keep up?
Well, continuing education is key.
Yeah.
There are specialized training programs, certifications that help technicians and engineers stay current with the latest and greatest. Because you wouldn't want someone working on a brand new aircraft using outdated drawings or techniques, would you?
No, definitely not. So it seems like there's no room for error in aviation. But beyond just keeping up with the new tech, are there any other challenges?
Absolutely. Aircraft themselves are becoming so much more complex, more sophisticated systems components.
Yeah, so I can imagine that makes the drawings even more intricate. It's like trying to fit an entire encyclopedia on a single page.
That's a great analogy. And it's not just about complexity. The rise of composite materials and advanced manufacturing techniques like 3D printing are also changing the way we represent and interpret drawings.
Right, so it really is a constantly evolving field. What about the future? Are there any trends on the horizon that you think could really shake things up?
Yeah, there are a few things that I'm personally really excited about. One is the increasing use of 3D modeling and virtual reality.
Wait, you mean like actually stepping inside a virtual aircraft and seeing the drawings come to life?
Exactly. Imagine being able to interact with those components, rotate them, zoom in, zoom out, all before the physical aircraft is even built. It's an incredibly powerful tool for design, training, and maintenance.
Wow, that's really next level stuff. Anything else?
Another really interesting development is the use of artificial intelligence and machine learning in the creation and interpretation of drawings.
Hold on. Are you telling me that there could be drawings that can basically think for themselves?
Well, not quite think,
Okay.
but they can certainly learn and adapt. Imagine a drawing that can automatically update itself based on real-world data or flag potential errors before they even happen.
That sounds like it could revolutionize the industry.
Yeah, it really has the potential to make drawings even more accurate, efficient, and intuitive. It's a really exciting time to be in this field.
I'm starting to realize that this whole world of aviation drawings is so much more than just lines on paper. It's a constantly evolving language that's essential for the safety and progress of flight.
Couldn't have said it better myself. It's a language that connects the dreams of engineers to the skills of technicians and really to the aspirations of all those people who step onto an airplane and take to the skies.
It really is incredible to think about the amount of complexity and precision behind something that most people take for granted. Next time I'm at the airport, I'll be looking at those planes with a whole new appreciation for the hidden language that made them possible.
That's what makes this field so fascinating. It's a world of intricate detail hidden in plain sight.
This has been a really incredible deep dive. Thank you so much for sharing your expertise and for opening our eyes to this hidden world of aviation drawings.
It's been my pleasure. And to all our listeners out there, the next time you board a flight, take a moment to appreciate the intricate language that made it all possible.
Until next time, keep exploring, keep asking questions.
And remember, there's always more to discover.
Thanks for tuning in to The Deep Dive.